Good morning students, welcome to our class. In previous video, we discussed the lesson about human eye and its colorful world. In that, the main points what we discussed about the least distance of distinct vision and the angle of vision. See, this least distance of distinct vision for a healthy person is 25 centimeters, and this least distance of distinct vision is different for the different aged people. Uh, for children below 10 years, its value is 7 to 8 centimeters. For a healthy human, it is 25 centimeters, and for the children below 10 years, this value is 7 to 8 centimeters. And for the old people, the least distance of distinct vision value is more, that is 1 to 2 meters or more than that. And one more point we discussed is the angle of vision. When you see any object, at what distance, if you can see the object without any strain to your eyes, that distance will call it as least distance of distinct vision of that particular person. Okay, so if you see any object, from the extreme portion of that object, the light enters to our eye and it makes an angle at the eye. So that angle will call it as angle of vision, and that value for a healthy human, its value is 60 degrees. If that angle is about 60 or below 60, that we can see the objects clearly. Without any strain. Or if that angle is more than 60 degrees, only we can see the part of the object. If that angle of vision is more than 60 degrees, we can see only the part of that particular object. These points we discussed in the earlier videos. Now coming to today's class, we have 5 sense organs. What are that? Ears, eyes, nose, tongue and skin. So in that, one of the sense organ is eyes. Due to that eyes, if you see any object, you can identify the shape, size, color, everything. You can identify the object due to the eye. So how our eye can identify the object, that we'll discuss in this video. So before going to that, to find out this, we have to learn the structure of a human eye. To find out how our eye identifies the shape, size and everything, to know that, we have to learn about the structure of human eye. See here, today we are going to discuss about the structure of human eye. See, in this, here I drew 2 diagrams. If you see the eye, normally we can see the eye, this is the front part of the eye. When you remove this eyeball means it is in the spherical shape, we will get like this shape. So this is the side view of the eye and this is the front view of the eye. Now first I will explain the front view. So these are the eyebrows, and if you see the eye part, here this part, it is completely white in color. This part, it is completely white in color. So this white part, will call it as sclera, and it is an opaque object. When light falls on this white part, completely it reflects the light. Next, after that white, we have a ball. It looks like black, and this ball is different for different people. Some persons, they have green color, bluish color, like a gray color, and for some people it is in black color. For the different persons, this part is different. So if you come to this part, This will call it as iris. In Telugu we'll call it as nalla guddu, we'll call it. So this will call it as iris. We'll call it as iris. This iris is very, very important in humans. Iris part is not the same for any human. It is completely unique for each human. Like fingerprints, how it is different for each human, like that, this iris part is also different, completely unique for each human. So that's why nowadays, actually for in the offices, schools and colleges, to take the attendance of the employees, generally on the register we have to sign, but nowadays they use a machine that will call it as biometry. In that biometry we have to give the attendance. Instead of that signing, either we have to press with the thumb or the fingers, or otherwise we have to give the attendance through our eye. Why? Because in the fingers also, the fingerprints are completely unique for each human. It is not matching with any other person, and even the iris also, it is completely different. So that's why newly this attendance, this biometry is introduced. Now coming to this iris part. Iris is a colored part, and this iris is helping the amount. When you see any object, if you see any object, this iris part is controlling the amount of light. Sometimes we can see the bright light, sometimes we can see the dim light, like that. So this iris is helping to control the amount of light that enters into our eye. Next, this iris has a black hole at the center. This iris has a black hole at the center. That will call it as a pupil. We'll call it as a pupil. See, this pupil is a hole. When light falls on the eye, the light enters. All these are opaque. Only the light enters through pupil only. The light enters through, if you see any object, when light from this object, the reflected rays are reaching to through pupil only, through pupil, and enters inside. So this is the external view of our eye. Now coming to the side view of our eye. When you remove our eye, it looks like a ball shape, spherical shape. So that's why our eye is a spherical shape. And if you observe, the front part is little bulged, or otherwise more sharp at the front side. So, and and the front part, it is a transparent layer, that will call it as cornea. Here I wrote it, see. The front part, it is a transparent layer, and we will call it as a cornea. It is the outer part of the eye. Next, behind the cornea, it is filled with a liquid, that will call it as aqueous humor. We'll call it as aqueous humor. And behind that aqueous humor, lens is there. We have a lens. And this, when you see this lens, it is in a previous lesson 4 we discussed about the types of lenses. In that we have convex, concave, and concave, convex, like that we have 5 or 6 types of lenses. But mainly we discussed about convex lens and concave lens. Now if you see the lens of human eye, is it a convex lens or a concave lens? If you observe this lens, the middle part is thick in middle, and at the edges it is thin. So it is a convex lens. Our eye has a lens that is a convex lens. That lens acts as a convex lens. So convex lens is known as a converging lens. So when you place any object in front of a convex lens, irrespective of the position always used to get the rays are refracted from the lens and it converges and we will get the image. So here also by using this lens and with respect to the position of the object, we used to get the refracted rays or converges and it falls on the screen. Here the screen will call it as a retina. Here when you see any object, the rays are refracted, and they will touch on your screen. This will call it as a retina. And the distance between the lens to the retina is the same, that is 2.5 centimeters. Once again repeating, important in bits, the distance between the lens to the retina is 2.5 centimeters. And one more we discussed, the least distance of distinct vision is 25 centimeters, that is 25 centimeters, and this is 2.5 centimeters, don't confuse. Okay, now this is the converging lens. So this I will discuss later. Next, coming to this aqueous humor and this lens, in between these two we have one muscular diaphragm that will call it as iris. A muscular diaphragm that will call it as iris, and this iris is a colored, already I explained, this iris as a colored part, and this colored part at the center it has a black hole that will call it as pupil. Okay, now for example, if you see in dim light, how does this iris always controls the amount of light. This iris always control the amount of, helps to control the amount of light to pupil. Not it controls, it is helping to control the amount of light enter into the pupil. For example, if you see, if you are in the bright place, then how you will see, like this you will see our eyes becomes contract. So if you are in a bright light, our this iris helps or control the pupil to contract. Contract means this is the big, then it becomes small. By controlling this pupil, the ciliary muscle is helping to control the pupil to become contract, that pupil to control. So when it is contract, then what happens, it avoids the excess of light that enter into this pupil. When you are in the bright place, so this pupil contracts, due to, for the contracts, this iris is helping the pupil to contract. When it contracts, what happens, it avoids the excess of light that enter into that pupil. Okay, now suppose if you are in a dim light, means not bright, it is if you are in dim light, then you will see like this, our eyes becomes expand like this. So in this condition, this iris is helping the pupil to expand like this, When the pupil expand, then more amount of light that it enter through the pupil, so that you can see the object clearly. So like that, this iris helps the pupil to control the amount of light enter into the pupil, either by contracting or expanding. So like that, here in the cameras we have the aperture. To see the object clearly, we have to adjust that aperture. So here this iris enables the pupil like that, and it acts as a variable. This iris makes the pupil to act as a variable aperture. Understand? Now, see, for example, we can see the far objects and we can see the near object. So what are the far object? You can see the sky. Sky is very far. It is at infinity. Even though you can see the sky. But you cannot see clearly, but you can see that is sky. You can identify. And you can see the near objects like this pen and on. You can see the near objects. At the far or near object, our eye always get the image at your distance of 2.5 centimeters on the retina. On the retina. Now, I will explain. Suppose if you see a far object like a tree or building or sky, how our lens, sorry, 1 minute, one more point I have to discuss here. When you see a far or near at different places of the objects, always used to get the image at 2.5. How it possible? Because the eye lens itself, it is adjusting its focal length. The eye lens itself, it is adjusting its focal length. Actually, the focal length of a lens depends on two factors. What are that? Focal length of a lens changes where depends on the material on which it is made, and the next one is the radius of curvature. On this two, the focal length values are changes. Here, eye lens itself, it is adjusting and always helps to form the image at a distance of 2.5 centimeters. And one more point we discussed, irrespective of the position of the object, in the concave lens and the convex mirror, we used to get the image at the same place. Wherever you place an object, we used to get the image at the same place. Here also, the eye lens itself, it is adjusting. How it is adjusting? That I am explaining now. For example, if you see a far object, very far, or otherwise building or the sky, then suppose this is your eye, this is the eye lens. This is the eye lens. Here, when an object is very far, generally when an object is far, the rays coming from the object are parallel. So the rays are coming from the object are parallel, means a parallel beam of light rays falls on the lens, eye lens, and when the rays are passing through the eye, refraction takes place. So here the refraction is taking place, and in this gap also it is filled with some liquid, mainly it contains water. So here water, and through the lens refraction takes place, and we will get the value, and the refracted rays will meet here. At this condition, the ciliary muscles are helping. So due to the ciliary muscles, the eye lens, due to the ciliary muscles, this eye lens, when you see a far object, the ciliary muscles are relaxed. Due to that the eye lens has its maximum focal length. The eye lens expands at a maximum focal length is 2.5 centimeters, means it's a focal length value. Eye lens focal length value is 2.5 centimeters. For example, if you see a very near object, then how our eye adjusts its focal length? Here, if an object is very near, the rays coming from the object are not parallel. So, we will get the rays like this. 1 minute. Here the eye lens is bulged like this. It contracts like this. Here the eye lens expands like this, and at this condition its focal length is 2.5 centimeters. And when you see very near object, the ciliary muscles are strained. When you see the far objects, you will not get any pain. But when you see the close object, near objects, the ciliary muscles are strained. Due to that, this eye lens contracts, and when it contracts, the rays coming from the object are like this, like diverging rays. And if it adjusts the lens, focal length of the lens, then we get the refracted rays forms at the retina. So like this, the ciliary muscles are helping to adjust this focal length by expanding and the contracting like that. When an object is near, our eye lens has a minimum focal length. Our eye lens has a minimum focal length, that is 2.27 centimeters. How much that? That is 2.27 centimeters. When an object is very far, our eye adjusts its focal length and its value is maximum, and its value is 2.5 centimeters. Okay, now coming to, if you see an object, how you can identify that? See, when the rays are passing through the eye lens, and through this eye lens we have one it falls on the retina. So here, coming to this retina is a delicate membrane. The retina is a delicate membrane, and it contains 125 million receptors. This retina, the image formed on the retina, this retina is a delicate membrane, and it contains 125 million receptors, that will call it as rods and cones. So we have the rod in that eye, we have rods and cones. Here C for cones, C, and cones, it identify the color. So C and C, like that you remember. Cones, it identify the color. Rods, it intensify the color, whether it is a dark or light or like that, the rods identify. Cones just identify whether it is a blue color, green color, like that it identify the color. And through these rods and cones receptors, whatever you see the object, that all the signals are passed through that, these are rods and cones, and through that the signals are sent to the brain through the optic nerve. Through the optic nerve, the signals are passed through the brain by the electrical signals. So our brain identifies that that is a pen or book or something, the object. Actually, if you see here, our eye lens is a convex lens. So convex lens is a converging lens. We get always real images. Real images means always invert images. Always invert images. So if you see an object, a pen, in our brain we will get like this shape. But even though we are not getting that pen is in the inverse position, immediately our brain senses that sense the position of this pen, shape, size, color. So that's why you will not get in the reverse condition, that the image of any object. So this is the structure of human